ஒரு நாளைக்கு 100+ ஆர்டர்ஸ் ஒரே ஒரு சின்ன ரூம்ல இருந்து, அதுவும் ஷாப்பே இல்லாம. இதை தான் நம்ம ஸ்மார்ட்டான தமிழ்நாடு செல்லர்ஸ் Hello.
Bye. Kind attention to the audience. Maintain silence throughout the function. Do not leave the hall while the function is in progress. We request the gathering to resume standing while the guests are entering the hall till they settle down. The program will commence in another couple of minutes. Please maintain silence and decorum of the institution. Please be seated. Happy morning to one and all present here. It's our privilege to welcome you all to the celebration of 75 years of IEEE Technology and Engineering Management Society, organized by IEEE TEMS India Initiative in collaboration with Sri Manakula Vinayagar Engineering College. Today, we commemorate the 75-year legacy of IEEE TEMS, recognizing its outstanding contributions to engineering, management, industry-academia collaboration, and the development of professionals who continue to shape the future of technology and innovation. With great pride and enthusiasm, let us begin this memorable celebration. Before every beginning, we remember the one who gave us our voice. Yes, the eternal mother of our language. Let us all stand for Tamil Thai Vazhuthu.
வாழ்வினில் செம்மையை செய்பவள் நீயே, மாண்புகள் நீயே, என் தமிழ் தாயே, வீழ்வாரை வீழாது காப்பவள் நீயே, வீரனின் வீரமும் வெற்றியும் நீயே, தாண்டிடு நிலையினில் உனை விடுப்பேனோ, தமிழன் என்னாலும் தலை குனிவேனோ, சூழ்ந்தின்பம் நல்கிடும் பைந்தமிழன்னாய் தோன்றுடல் நீ உயிர் நான் மறப்பேனோ, செந்தமிழே உயிரே நருந்தேனே, செயலினை மூச்சினை உனக்களித்தேனே, நைந்தாயனில் நைந்து போகுமென் வாழ்வு, நன்னிலை உனக்கெனில் எனக்கும் தானே, முந்திய நாடினில் அறிவுமில்லாது மொய்த்தனன் மனிதராம் புதுப்புனல் மீது செந்தாமரை காடு பூத்தது போல செழித்த என் தமிழே ஒளியே வாழி, செழித்த என் தமிழே ஒளியே வாழி, செழித்த என் தமிழே ஒளியே வாழி.
Let us continue standing for SMVEC anthem.
நாயகா விநாயகா ஸ்ரீமணகுல விநாயகா, நாயகா விநாயகா ஸ்ரீமணகுல விநாயகா, நல்ல கல்வி தந்தாய் விநாயகா, வாழ்வை சொல்லி தந்தாய் விநாயகா, இன்பம் அள்ளி தந்தாய் விநாயகா, ஸ்ரீமணகுல விநாயகா, நாளைய வாழ்வினை வெற்றி கொள்ளவே நாங்களும் இங்கு வந்து கற்றுக்கொள்கிறோம், ஸ்ரீமணகுல விநாயகர் கல்வி கூறுவோம், மனதுக்குள் நன்றி சொல்லி நாடும் மகிழ்வோம், உந்தன் துணை வேண்டும், உந்தன் அருள் வேண்டும், என்றும் ஜெயமாக உந்தன் வரம் வேண்டும், நாயகா விநாயகா ஸ்ரீமணகுல விநாயகா.
Please be seated. Every great institution has a story to tell, a story of vision, dedication, perseverance, and success. We are delighted to present an audiovisual showcase of Sri Manakula Vinayagar Engineering College. Please sit back and enjoy the presentation. Thank you, team, for the captivating presentation. Let's begin this propitious day with a traditional lamp lighting ceremony as a tribute to the goddess of wisdom. Now, I call upon the dignitaries to light the lamp. Lighting the ceremonial lamp, kindly occupy the seats on the dais. It's my great pleasure to introduce our respected Director cum Principal, Dr. V.S.K. Venkatachalapati. Sir is a distinguished academician and visionary leader with over 37 years of experience in engineering, education, academic administration, and institutional development. With this note, may I request you, sir, to deliver the welcome address to the gathering.
Respected Chief Guest, respected Treasurer of Sri Manakalavanakar Educational Trust, distinguished invitees from various parts of the country, respected IEEE TEMS leaders and members, respected deans and faculty members, and my dear and beloved, the most lovable students. It gives me immense pleasure to welcome you all to IEEE TEMS Horizon 75, the Managing Technology for Humanity, organized by IEEE TEMS India initiative in collaboration with Sri Manakalavanakar Engineering College. Really, it's a wonderful event. In the celebrations of 75 years glorious of this IEEE technology and engineering management, the society, the number 75 is not a mere number. It's a journey of vision, resilience, and excellence from humble beginning to becoming a beacon of technological educations and innovations, and also has nurtured countless engineers, thinkers, and leaders who have contributed to the society in a meaningful way. Today, we are all standing on the shoulders of that rich legacy. We also look forward to new ideas, new technological concepts, and new possibilities in the field of engineering and the management. In this context, the role of professional societies like IEEE, the TEM, becomes even more significant. The IEEE Technology and Engineering Management Society, in particular, bridges the gap between the technology and the leadership, helping us to understand not only how to build the system, but also how to manage the projects, lead teams, and drive innovation responsibilities. Really, we are deeply honored to welcome all the dignitaries on the dais and off the dais. At the foremost, we are deeply honored by the gracious presence of our distinguished the guest. I extend a special welcome to Dr. Suchindra Kaushik, the President of IEEE, the STEMS, whose leadership continues to strengthen the global TEMS community. I sincerely extend my warm welcome to you, sir. We are privileged to have Dr. Parkumaran, the chair of IEEE TEMS India, for his constant initiatives and motivations, whose dedication has been instrumental in fostering the growth of STEMS activities across the India. I sincerely extend my warm welcome to you, sir. I take this opportunity to welcome the young dynamic Sri D. Rajarajan, the Treasurer of Sri Madras Nagar Educational Trust, for his youthful the guidance and inspiring the ideas which makes a lot of transformations. I sincerely extend my warm welcome to Mr. Rajarajan, sir. I also should the welcome the beloved the Chairman and Managing Director of this Madras Nagar Educational Trust. At present, today he is not present because of the preoccupations. However, he has conveyed the great wishes for the grand success of the great function. I sincerely welcome our Chairman and Managing Director also. We are delighted to welcome Dr. Shai Narayanan, the Vice President, HCL Technology, who is giving to share a valuable industry perspectives, AI-driven innovation, solving tomorrow's engineering and the management concepts. It is my duty to welcome our esteemed panelists, Dr. Mausikakar, Dr. Arun, Dr. G. Kulandevel sir, and Dr. V. Nagarajan sir for their valuable presence and to extend their constant support in establishing the various technological concepts to our own lovable students. I also extend my welcome to our own the respective deans, Dr. A. Jaykumar, Dr. Anvumalar, Dr. A. Arivalagar, Dr. Velmurugan, Dr. N.S.M. Kailasam for their constant support rendered for every successful event which we are organizing in this event. I warmly welcome you all. I extend my warm welcome to all the heads of the departments, faculty members, teaching and non-teaching staff members, technicians, the media personnel, cameramen, and supporting staff members for organizing this wonderful event in the campus. As we celebrate 75 years of IEEE TEMS, let us also recommit ourselves to the values that we have guided us: academic integrity, social responsibility, then continuous learning, and the courage of innovations. Let this TEMS event to be a platform where the ideas are exchanged, collaborations are formed, and new aspirations are ignited. Once again, on behalf of the Madras Nagar Engineering College and IEEE TEMS Society, I welcome you all to this milestone celebration. May the discussions today inspire us to carry forward the legacy of the past 75 years and shape the even brighter futures. Thank you, and I wish you all success in this letter. Thank you, one and all gathered here.
Thank you, sir, for your warm and gracious welcome. It's time to honor the dignitaries on the dais. May I invite our treasurer, Sri D. Rajarajan sir, to honor our chief guest Dr. Susindra Kaushik, President, IEEE TEMS. Thank you, sir. May I invite our Director cum Principal, Dr. V.S.K. Venkatachalapati, sir, to honor our guest, Dr. Porkumuran Karandara, Chair, TEMS India. Thank you, sir. May I invite Dr. S. Anbumalan, ma'am, Dean Academics, to honor our guest, Dr. Mauchiki Kar, Secretary, IEEE TEMS. Thank you, ma'am. I request other IEEE TEMS members to be on the stage.
Raja. Sir.
I request our Director, sir, to honor Dr. Arun Tangsali, Treasurer, AVP member. It's time to celebrate a remarkable milestone, 75 glorious years of IEEE Technology, Engineering and Management Society. This Diamond Jubilee marks a legacy of innovation, leadership, and excellence in engineering management. I request our esteemed dignitaries on the dais for the 75-year celebration cake cutting ceremony. Ladies and gentlemen, please join me in a warm round of applause as our dignitaries commemorate this historic occasion by cutting the celebratory cake. Happy 75th anniversary, IEEE TEMS. Looking forward to many more years of inspiring innovation and excellence. Thank you all for joining us in the cake cutting ceremony. I request our director, sir, to honor our treasurer. I request Dr. P. Raja, sir, to honor our director cum principal. Thank you, sir. It's my great privilege to introduce our esteemed guest, Professor Dr. K. Porkumaran, sir, Senior Professor and Principal of Sri Krishna College of Engineering and Technology, Coimbatore. He is an accomplished academic leader with over 30 years of teaching, 21 years of research, and 20 years of academic administration. As specialist in control systems engineering, he has made significant contributions to research, innovation, and engineering education. He is a fellow of the Institution of Engineers and IEEE, a senior member of IEEE, ISA, and has served in several prestigious leadership roles, including immediate past chairman of the IEEE Madras section, president of IEEE TEMS India, and chair of the IEEE Reliability Society Madras chapter. An outstanding researcher, he has published over 175 research papers, 22 book chapters and secured more than 6 crores in research funding and guided 14 PhD scholars to successful completion. His pioneering work in defense innovation has earned him recognition from the Ministry of Defense, and he was felicitated by the Honorable Raksha Mantri at DEF Expo 2022. His numerous accolades include the ISTE National Award for Best Engineering College Principal, IEEE Outstanding Engineer Award, CSI Distinguished Principal Award, and FICCI Startup Leader of the Year Award. With this note, may I request our guest, Dr. K. Porkumaran, Chair, IEEE TEMS India, to kindly deliver the inaugural address.
Good morning to all. Most distinguished gathering here, most esteemed Treasurer Sri Manakula Vinayagar Educational Trust Sri D. Rajarajan Sir, Sri M. Dhanasekaran, Chancellor Dakshila University, Chairman and Managing Director of Smvec, most respected and beloved Professor Dr. V.S.K. Venkatajalapati Sir, Director cum Principal Sri Manakula Vinayagar Engineering College, the organizing convener Dr. Raja, Professor of Manakula Vinayagar Engineering College, esteemed Deans of Manakula Vinayagar Engineering College, Professors, our esteemed President IEEE TEMS Global Dr. Sudhindra Kausik, our Secretary IEEE TEMS Global Dr. Mausikikar, our Associate Vice President TEMS Global Membership Dr. Arun Tenkasli, and other esteemed members of IEEE TEMS Global as well IEEE TEMS India, Professor Dr. G. Kulandevel, IEEE Madras TEMS Madras Chapter, Dr. Yadi, for past Chair of IEEE TEMS Bangalore Chapter, Dr. Nagarajan, Vice Chair of IEEE Madras Section, Dr. Sanmuganathan, Vice Chair of IEEE Madras Section, Dr. Arun Madhyalagan from IEEE Madras Section, and all other distinguished members of IEEE TEMS, the distinguished delegates from Pune Section, Sai Prasant, Sai Kumar Tara, Dr. G. Soyanarayanan, and other distinguished members of IEEE volunteers of IEEE Global and IEEE India level. And my dearest student friends, very good morning. Very good morning. It's a great honor and privilege for me to be part of this wonderful gathering on celebrating 75 years of the IEEE Technology and Engineering Management Society. It's one of the important celebration. We're all gathered together for the common objective, vision, mission of IEEE, advancing for the scientific community based on the cross-disciplinary, interdisciplinary approach, methodology of IEEE Vision 2030. The tagline of IEEE changed into professional home for engineering technology community worldwide. That is in line with the vision and mission of IEEE TEMS, Technology and Engineering Management Society, which inculcates culture of collaboration, innovation, and brings a lot of innovative thought process for the benefit of the scientific community in nature. Particularly IEEE 150 plus years of professional society, many industry experts, academicians worldwide, they are part of this community, serving for the scientific advancements. There are many societies, there are many technical communities, local groups available. 3 major groups were young professionals, Women in Engineering Affinity Group, and Special Interest Group on Humanitarian Technology, serving a lot for the benefit of the scientific community, especially students community, professionals, researchers in a large. Dear students, This is not only a celebration, it's a coming together, planning together, doing something for the benefit of the community in a large. As a professional or engineering student or a faculty, technocrats, we have social responsibility. Giving back to the community is a joy of giving. So technological advancements will be happening through IEEE. Skilling, upskilling, reskilling initiatives are being taken care by IEEE TEMS. And many significant innovation ecosystem inculcated in the process of IEEE TEMS. I am sure this celebration, your journey connected to IEEE and any professional community will be much helpful for your advancement. I would like to add 1 or 2 points here. There are very significant initiatives by IEEE and IEEE TEMS. To name a few, Collaboratech. Collaboratech is a powerful tool which connects together with the professional community. Effective mentorship mechanisms with the Collaboratech is like a LinkedIn. And when you contribute through humanitarian technology initiatives, there are many schemes like engineering projects in community epics, tech for good under SITE, special interest group on humanitarian technology. If you have an idea to convert your idea with the creativity into a product, then entire business model operations is supported by IEEE TEMS. And there are many recognitions from IEEE, many awards and recognitions like Oscar Award for many professionals, Doral Chong Award, Richard E. Mervyn Award, Epsilon Award, Outstanding Volunteer Award in national level and global level. I hope and expect you will be part of this journey and you'll do something back to the community in terms of product, technology, software, and many. And you'll enjoy the volunteering journey when you be part of this IEEE. On behalf of IEEE TEMS India, IEEE TEMS Global, our heartiest thanks and gratitude to most respected Chairman Sri M. Dhanasekaran Sir, Chancellor Dakshila University, and Sri D. Rajarajan Sir, Treasurer Sri Manakula Vinayagar Educational Trust, and special thanks to our most respected and beloved Director and Principal, and all the Deans, very dynamic team of volunteers here for making this event a memorable one. And I hope and expect it will be one of the milestone in the brief and illustrious history of IEEE as well with Manakula Vinayagar Engineering College. I hope and expect the journey continues with a lot of collaboration between IEEE, IEEE TEMS and Manakula Vinayagar institutions to bring out innovation to impact for the benefit of the community in a large. Thank you so much once again for giving this wonderful opportunity. Thank you.
Thank you, sir, for briefing the significance of IEEE TEMS. It's my honor to introduce Sri D. Rajarajan Sir, Treasurer of Sri Manakula Vinayagar Educational Trust, a graduate in computer science engineering with business systems from the University of Birmingham, UK. He combines global academic excellence with visionary leadership. He plays a pivotal role in the strategic growth of the institution, driving excellence in administration, innovation, student development, and academic transformation. He also serves as the Chief Executive Officer of InBazaar and Bloomby Technologies, where he leads business strategy, digital transformation, and technology-driven innovation across multiple sectors. A dynamic leader with a passion for education, entrepreneurship, and innovation, he continues to inspire institutional excellence and sustainable growth. With this, may I invite you, sir, to deliver the presidential address to the gathering.
Good morning, everyone. First of all, I would like to extend my warm welcome to Dr. Susindra Kaushik sir, and Dr. Porkuman sir, and all the other IEEE dignitaries who's present on the stage and off the dais. And I would like to welcome our director, deans of all the department, staffs, and mainly students. I would like to extend my warm welcome to each and every one of you. So first of all, we are so glad to host this prestigious event of this IEEE TEMS for celebrating the 75 years of glorious years. And they could like, we are having a conversation in the morning. They say that they could have hosted anywhere in India, but they decided to host it here. We are so glad to host them and be part of this wonderful celebration. So yeah, so it's been so it's been 75 years. 75 years means like like the organization is founded literally, like I think all older than like all of us who was present in this auditorium. So so we're so glad to be part of this prestigious organization. So this 75 years gives an opportunity to look at the engineering in 3 stages. So imagine an engineer who comes from like 75 years before, and today he comes and sees our smartphone. He might ask like, okay, what department or what discipline does this engineering belongs to, like the mobile phone? The answer is it touches almost all departments of engineering. So that's that captures the journey of engineering from the specialization to convergence and now towards the intelligent collaboration. So in the past, engineering was largely the age of the specialist. The civil engineer mastered structures, and a mechanical engineer mastered machines, electronic engineer mastered circuits, and electrical engineer mastered power. But each engineering department was like a specialized workshop. That is, I'm not saying it is wrong. So because you can't build a bridge build like entire bridge with a shallow understanding of it, right? Or you can't build a aircraft without the depth understanding of it. That is because before, in the past, the tools used to be very limited, and it needs like a lot of modeling, physical modeling, and a lot of prototypes, and so tools were limited, but we need a tremendous amount of judgment. Those things are still relevant in today's age, but I believe it is not enough for today's day and age. Every engineer still needs depth, but today depth is not enough. And second feature of the past is major innovation usually require major organization. Like many people might have like a brilliant idea, but still in order for the brilliant idea to be executed, they still needed laboratories, they still needed computers, they still need manufacturing facilities and specialized teams, and most important, major funding. So in the past, innovation is like literally like producing a film. Many people can have like a great stories, but if you want to make that story into a reality, you need a crew, you need a technical team, you need a sound, music department, you need hundreds and hundreds of the people and major funding in order for that story to be reality. So the engineering was like that in the past. It need like support of the major cross discipline in order for to make that vision into a reality. But that situation has changed drastically in today's day and age. Today, major innovation happens at the intersection between disciplines. Say, for example, if you take a smartwatch, it requires sensors, it requires software, it requires AI, it requires communication network, it requires material science, it requires medical expertise, it requires management for management to make it affordable. So today's engineering combines like most of the multiple disciplines together. So no one department can claim ownership of that specific product like a smartwatch. It is like a jigsaw puzzle. Children use now, like they will combine a lot of like small puzzle to make a picture. Like even like each and every piece is important in that. Even if one piece is missing, you won't see the full picture. So all the disciplines are important in order for today's engineering. If you take robotics, it combines mechanics, electronics, software, AI. If you take modern agriculture, it requires drones, satellites, sensor, biotechnology. If you take healthcare, it increasingly combines medicine, engineering, and computing. But the department preserve knowledge, but the intersection create breakthroughs. You can, the modern engineer, you can think of it as like a T-shaped. Think about the T-shape. Like if you take the vertical line, you have to be deeply specialized in one thing. You have to be, you have to provide expertise. You have to know the nook and corner of everything, which is the vertical line. Along with that, horizontal line. That horizontal line, you have to have awareness and all the like generalization of like all the other discipline. So if you combine them only in today's day and age, you will be able to create something worthwhile. And also another important change that is happening today is engineers are becoming entrepreneurship. This is because of the access to cloud computing and open source software and affordable sensor, 3D printing. Because like I told now, like in the innovation, before the innovation needed a large laboratory, but today you can just use one for like for the innovation. So the distance between the idea and the prototype has reduced drastically. Many people get it wrong, like entrepreneurship, they think that it is registering a company. But in today's day and age, registering a company is like can be done in 24 hours or like within 1 week's time. That not matters. What entrepreneurship is taking ownership of the entire journey from the technology to the engineering and to make it affordable and make it reach people. So I think that's where the IEEE TEMS becomes extremely relevant, because technology creates possibility, engineering proves that it can work, and management ensures that it reaches a lot of people in an affordable way. So these are the most, so the engineer should stop asking like, can I build it? No, they should be asking, can I make it useful for the masses? That's a main thing that should ask. Next, this is the present scenario, and I would like to paint a picture how the future will look like. In the real world, what is it? Generally, like in our colleges, or like if you take any colleges, like it is usually compartmentalized into various departments. I think the future is going to be how it's going to be now. I don't think it's going to be department specific like the future. The future, for example, if it is going to be problem specific. Say if you take the problem of climate change, it is not a one department which can solve. Environmentalists alone can't solve this issue. It needs like from policy level to transportation to construction, electronics. So for make any significant change in the climate contribution in climate change, like all the various things needs to work. Say for example, if you take affordable healthcare, like it requires biotechnology, electronics, telecommunication. So in the future, like engineering will be increasingly organized around the problems rather than the specific department. So one challenge, how can we provide meaningful medical diagnosis to a rural village? That will be one problem statement that future engineers will be working towards. So it requires doctor, like it requires people from all the domains. Another final thing that is going to happen in the future, that is already happening, is going to be there is be a major impact in the AI will be like a future collaborator. That will be it will be more like a partnership with the we will be have a deep partnership with the artificial intelligence. Many people think that will it replace engineers, something like that. So like when the calculator is invented, it didn't replace mathematicians. When the CAD designs are invented, it didn't replace civil engineers. I believe it is the same thing going to happen with the AI as well. It's going to be an incredible collaboration tool rather than a replacement tool. For example, if it can generate hundreds and hundreds of designs, and it could simulate performance, it could identify weakness, but end of the day we need judgment, like what is right and what is wrong. Okay, this is right, this is wrong. So we need to think it as a co-pilot. Like co-pilot will help you with everything while flying the flight, but end of the day pilot has to decide where it needs to land, what time it needs to land, how to take that. So ultimately the decision is going to be on the hands of us. When we need to treat that AI as a collaborator. So in conclusion, so engineering, like I told, engineering has gone through a lot of things in this past 75 years. Like we told, it used to be specialist, now it is at the intersection of discipline. In the future, it is going to be problem-oriented, problem-focused, and AI as a collaborator. This is the two major things that going forward will be going forward, I think. And once again, thank you for providing me this opportunity, and it's an honor that we could celebrate with them. And thank you for providing. Thank you.
Thank you, sir, for the enlightening words. It's my privilege to introduce our guest, Dr. Sudhindra Tirtha Kaushik, President of IEEE TEMS. He is a globally recognized innovation leader, entrepreneur, technology management professional, and an accomplished IEEE volunteer with over 3 decades of international industry experience spanning India, Singapore, and the Netherlands. His distinguished career includes leadership roles at renowned organizations such as Philips, NXP, HCL, TTK, Prestige, and Volvo Group, where he has driven innovation, technology management, intellectual property, and organizational transformation. A 2-time TEDx speaker, accomplished innovation consultant, author, mentor, and contributor to more than 50 patents and innovation disclosures. He has inspired industries, startups, and academic institutions worldwide through his expertise in innovation, entrepreneurship, research, and engineering. He is also a cartoonist, TV, and cinema actor. With this note, may I invite Dr. Sudhindra Tirtha Kaushik, sir, to deliver the keynote address.
Vanakkam. Oh, okay. So good morning didn't work, Vanakkam worked. Good morning. No. Good morning. Okay. So thank you for having us here. So why are we here? So we represent IEEE TEMS, but more importantly, what Rajarajan said was that when you look at something which is as old as 75 years, you realize that, yeah, perhaps nobody in the room was alive when this was born, right? So, but actually if you see IEEE itself, how many of you are IEEE members? You can raise your hand. Okay, not too many, but that's good. That's why we are here, okay? So, why do you need to become IEEE member? Why do you need to do what you need to do? First thing is, when you understand why we are here, as an institute, a very great institute, and such an institute needs visionary leaders to start this kind of an institute, and we understood how many students are here as a group, 25,000 people getting educated, over 4,500, staff is not a joke. It's very, very, very impressive, and it's already 26 years of doing that. So it's fantastic to be in this university. And as you enter, you will feel the vibes of a great place where you want to learn, where you want to come back. So this was a place where we felt, wow, this is a nice place to come here. And thank you again for hosting us here. IEEE was started by people like Thomas Alva Edison, okay? Nikola Tesla and those kind of people. It's 140 years old. When you look at what happens in a society, as and when new technology comes, education also gets challenged. At some stage, we were also like you. people on the dais were also students. We were also sitting there wondering what happens next 2 years, 3 years. Will I get a job? Will I not get a job? And honestly, when I was your age and stage, I couldn't speak English. So I thought my life is over because I cannot speak English. You will feel like that, and it's normal. But you will overcome that, and one day you will be on the stage giving the same kind of address that we are talking to you. But what you need to understand is it will not happen automatically. When you stop engineering and when you either you become a researcher, either you start working in a company, or maybe some of you start your own company, whatever may be what you choose to do, learning has to be continuous. Okay? Once engineering is over, don't think you're done with learning. There are two kinds of learning. When you go to a college, it's a formal learning. When you learn on your job, working with people, it's on-the-job learning. So on-the-job learning becomes more important once you finish engineering. And where do you get this on-the-job learning? By being part of communities like IEEE. So when you look at what is the future of education, all of you can make a note in your phone or in your mind. Google sometime called World Economic Forum, WEF, World Economic Forum, future skills. What you should learn to be future proof. There is a concept called half-life of education. Half-life of education means when you start learning something, after how many years it becomes half useful, that means half useless. Okay? In the late 90s, people used to join a company and retire from that company, same company. So the half-life of education was close to 40 years. Today, what you are facing, half-life of education is 2 years. That means even before you come out of your own college, half of what you studied is challenged. That means learning becomes even more important. Where do you learn? Education Limited, and Rajarajan talked about AI, Copilot and everything. It helps. It does help. There is no doubt about it. But what is proven even with AI is your own thinking ability. Are you able to think on your own? I am from the industry. Okay? I am basically from industry, though I have been part of academia as well. What do we look in industry is how each of you can solve a problem. Basically, we are looking for problem solvers. I could be vice president in TTK Prestige, but I wouldn't know all the problems, and I definitely wouldn't know how to solve all the problems. So we need people who can solve problems. Now, problems have become complex problems now, because every technology, again, Rajarajan gave a very nice example, a simple movie, well, not a simple movie, it's a very complicated process to make a movie. And you can think how many things should come together to make a movie, or a simple phone, or even a photograph, or a display, everything. So interdisciplinary working is very important. So whatever branch you are in, your learning and problem solving becomes your asset. Everybody will have a degree, but your solving skills and understanding problems require 4 skills: critical thinking, analytical thinking, creativity, and complex problem solving. Okay? All of this will mean that you have to solve more problems to get more comfortable with each other. Now you have to work with interdisciplines. When I come and interview for a job in say Siemens or Philips or whichever company, I will not look how many marks you get. That is okay, that is done before the screening. But once you come to the interview, I'll ask you questions about how do you know about which technology. So exposure is very important. Now where do you get all this training, this critical thinking skills, analytical thinking skills, management skills, is by being part of societies. When you are in college, you have different learning. After college, you have to be part of societies. And this, what we are talking about, is invaluable skills. If you are a researcher, for example, then you can publish papers. But more importantly, you can learn how to work with each other, how to work with Porkumaran in Coimbatore, or maybe somebody else in another state. How do you work with industry? Most times I used to work with academia, they used to struggle because they work differently than us. Industry works differently than academia. But if you learn that, you will be a valuable asset. Now, suppose you are not an education, you are not going to research, I want to become an entrepreneur. TEMS also has something for entrepreneurs. How do you develop an idea which has an impact? 95% of the startups fail, not because the people are bad who are running the startup. 95% of the startups fail because the number one reason is they build what nobody wants. Now, how do you know what somebody wants? That's not in any of your books. but books will not help you learn that as well. But working with entrepreneurs, and when you join a society like TEMS, you will know people from New Zealand to Egypt to Latin America to Canada. You will just know everybody who is best in the business, and that's called exposure. Everybody in this room can get that, but everybody in the room will not get that because if you don't take the action. So you need to make an attempt. How do you make yourself different than from the other 10,000 people that are graduating? That's in your hands. I always say the gain is with you, the loss is also with you. You need to understand what you need to do beyond education to do. By joining societies like this, you will get to a point of time where you say, I'm more confident. How do you become confident in anything is by practicing. And how do you practice is by working with the best of the people. So people on the dais and people off the dais, we are here the whole day. Put together, we might be having around 600 years of experience between us, the 25 of us. So it's up to you. We are giving to you in a single day in a platter, and you can pick it up and see how you want to use it. And like I said, everybody will do different things. You don't have to be an entrepreneur. You don't have to be an employee. Whatever you choose to do, you have to do it well. And that's the whole idea of becoming a part of a society. Is what is well is when you rub shoulders with people who are already experienced, you will learn a lot from them, right? We just got joined by our special speaker today. He will talk about how industry is looking at innovation, what you can learn. So opportunity is there. People tell me the future belongs to the youth. I wish. The future does not belong to anybody. The future belongs to those who go and get it. So if you want to get it, you have to go and get it. And you can start your journey by being part of societies and being part of events like this. It's not easy to organize an event like this. So I thank the entire team at the Institute, but also at TEMS, who are part of here, the dais and off the dais, to have made this a fantastic opportunity. But I invite you, my dear students, to make use of it. If you are a shy person, practice today to go and talk to somebody. Just say hello and say your name. Okay, that's all. Don't ask anything, don't say anything more. Just challenge yourself, and once you do that, first time is hard, second time is harder, third time is easy. Okay, but if you don't take the first step, it becomes very difficult for you to grow because nobody understands what is in your mind. You need to learn how to speak as well. Okay, like I said, we are all here till the second half of the day. Come and talk to us, be part of TEMS and be part of IEEE. Organize such events, and like Porkumaran was saying, some of the things IEEE offers is only when you do it yourself. Okay, how do you deal with people? How do you deal with an event and so on? So I invite you all once again to join us today, and thank the Institute for hosting us on this momentous occasion of 75 years of TEMS and 26 years of the Institute itself. Thank you very much.
Thank you, sir, for the inspiring and insightful address. Let us honor our guest recently joined with us. I request our director, sir, and treasurer, sir, to join in honoring our guest, Dr. G. Sai Narayanan, sir, Associate Vice President, HCL Tech. Thank you, sir. We now move on to one of the most anticipated sessions of the day, a panel discussion on building careers with IEEE TEMS. To moderate this insightful discussion, it's my pleasure to invite Dr. Samiksha to the stage. With her expertise and experience, she will lead an engaging conversation with our distinguished panelists. I request TEMS India members to honor our treasurer, sir, I request TEMS India members to honor our director cum principal, sir. I request the TEMS India members to honor Dr. P. Raja, Professor and Head, Department of Electronics and Communication Engineering. Thank you, sir. I request the TEMS India teams to honor our respected deans. I request the Controller of Examinations, Dean Placement, Dean Research and Development, Dean Academics, Dean Academics, thank you, sir, and thank you, ma'am, for doing the honors. I thank the dignitaries on the dais.
Hello.
Good morning, esteemed guests, volunteers, IEEE TEMS member, college members, and all the future engineering leaders. For 75 years, IEEE Technology and Engineering Society has stood at critical intersection where technical genius meets visionary leadership. In today's landscape, being an exceptional engineer is only half the equation. Knowing how to lead, manage the disruptive technologies, and drive societal impact is what defines a successful career. Today, as we celebrate 70 of IEEE 10, we are not just looking back at history. We are unpacking the exact roadmap for our students, faculty, and institutions to learn this global network for career readiness, institutional excellence, and global innovation. I am Samiksha Shukla. I am from Global Academy of Technology, Bangalore, and I am senior member of IEEE Bangalore section and IEEE TEMS Society. It is an honor to be with you all for getting to know from is that what exactly we should do to be a member of IEEE TEMS and what are the benefits which we can get. So we have with us our esteemed panelists. I just request all the panelists to give a brief introduction.
Hello everybody, a very good morning. I'm Professor Moshiki Kaur. I serve as the Secretary of IEEE TEMS globally, but my day job is as a faculty member and teacher to students such as yourself in the Department of Electronics and Communication Engineering in Heritage Institute of Technology, Kolkata. Good to be here.
Good morning. Welcome all for this IEEE 75th celebration. I am Dr. G. Kurandaivel, Professor and Head Department of Electronics and Communication Engineering, National Institute of Technical Teachers Training and Research under the Ministry of Education, Government of India in Chennai. I am also Chairman of IEEE TEMS Madras chapter. So I am in Nitha Chennai for the past 30 years. We conduct training program for the teachers of engineering colleges and polytechnics, universities from 1964. Okay, thank you.
Good morning, everybody. Great to be here at the 75th years celebrations of TEMS at this particular institute. A great environment and vibe here. So my name is Arun Tangsali. I am currently the treasurer of TEMS. But in my professional life, I come from the industry. I started a couple of companies. I've been working in the software industry for the last 35 odd years. So several companies, lots of products, lots of customers around the world. So all the things that TEMS really looks for of taking ideas to a product, to market and making it succeed. I think gone through that journey and see how TEMS can add value to every engineer. So great to be here and thank you for having me on this.
I am Professor Porkumaran Karantaraj, Chair IEEE TEMS India, Vice Chair of Sustainable Development Activities, Committee of IEEE India Council. In simple word, innovate to impact with the theme Technology and Engineering Management Society, taking significant initiatives and contributions for the advancement of scientific community. I welcome all of you to join with this community, to enjoy your innovation thought process, to convert your idea into a product, convert your idea, knowledge into a business model. Having a startup as said by your chairman of this esteemed college.
Thank you. I'm Sudhindra Kaushik. At heart, I'm an innovator, basically an engineer. So I would like to see if some of you will ask some questions when we have the panel discussion. Okay? Thank you.
So, thank you, sir. Thank you all. When most people hear the word innovation, they think of sudden eureka moment. But our special guest has spent his career proving that true innovation isn't an accident. It is a deliberated discipline. It's innovation by design. So my first question I want to pose to Dr. Sudhindra Kaushik. Sir, today's rapidly changing workforce, what is the single biggest shift an engineer needs to make from being a technical executor to an innovator?
Yeah, I think it's perhaps the most important question that if I were you, I would be thinking about. Innovation is considered as the skill of the 21st century. That means it can solve most problems. But innovation has two parts. Understanding the problem, then solving the problem. It's called problem solving, not solving problem. Okay? Problem solving means you get the problem first, understand the problem first, and then find a good solution. When I mentioned 95% of startups fail, they didn't understand the problem, but they came up with a solution. A good solution to a bad problem is a bad innovation. A bad solution to a good problem still has hope because you can find a good solution. So it's very important that you spend time understanding a problem, and most of our education is about solving problem, not finding problem. So if the shift, if I may answer, is that if you can practice finding good problems, you will be very, very, very valuable to industry and to the society in general. Even if you are in research, publication is not the outcome, impact is the outcome. So even if you do a PhD, the research problem should be a good problem. If you go to a doctor, he cannot just give you medicine without knowing the problem. So a headache has 157 known reasons. So if I don't know the reason for the headache, I can give you the wrong tablet, right? So understanding the problem would be my big takeaway from this.
Thank you, sir. I love the thought. Understanding problem is very important. So when you understand the problem, your solution will be coming out, which is really going to be the useful solution. Now I would like to move to Dr. Mauchiki. Mauchiki madam has diverse leadership in IEEE TEMS Society. I would like to know, as a secretary IEEE TEMS and the chair of women in IEEE, what unique leadership and mentoring pathway does the society offer to young women looking to break the glass ceiling in engineering management role?
Yes, first of all, I would like to point out that I'm elated that majority of the audience here are girl students. So the topic or the question that you've put to me is very essential here, and I feel that it will come to use to most of the students here. So IEEE TEMS, as Sudhindra sir has mentioned earlier, that it gives you a career pathway, it helps you achieve your dreams. by rubbing shoulders with giants in the industry, in the academia, entrepreneurs, and policymakers around the globe. That's true for everybody, right? But technology has two parts. One is development of technology, the other is deployment, right? So while development of technology needs engineering skills, deployment would need management skills. So while engineering problems are difficult, you would be amazed to note that deployment, which needs management skills, requires to manage people. That's very, very exceptionally difficult, okay? So managing people, managing risks when you try to deploy a solution, that is also something that you learn when you're part of IEEE TEMS. But let me come to the second part of the question where you're talking about women in particular. I would say that women have a different journey. Though not always difficult, often it is difficult, but it is a different journey from men. Because when you progress in your career, when you are at the most crucial point of your career, you're also in the most crucial point of your life as a woman, where you're a homemaker, you have to take care of your children, right? So that's a very important phase of being a woman, but that is again a time when you need to progress in your career. How to handle that? That sort of hand-holding is something that we look forward to giving you when you're a part of Women in TEMS. How so? Number one, you could be a volunteer with us right from your student days. You could mingle and come in touch with women across the globe, okay? So you can come in touch with them and know how they dealt with the problem. You don't need to reinvent the wheel. Take cues from their experience and progress your career. Again, you can also organize activities such as this, right? And you get to know how to manage people and implement leadership, because leadership is something that you cannot teach in a school, right? You need to implement it by actually doing it. And you get several opportunities if you're a part of Women in TEMS. We have several initiatives where we have special spotlights where we can showcase what you're doing. And I guess be a part of Women in TEMS so that we can handhold you as you progress throughout your career. That's my 2 cents. Thank you, Samiksha.
Thank you, ma'am. So I hope most of the girls here would be willing to be starting with a volunteer role. And now I would like to go to the next perspective, little bit flipping the coin. So I would like to ask Dr. Borukumaran, as an academic leader, and representing IEEE at various forum and in various capacities, if the student community want to know how they transit from the textbook to the opportunities which will be on the job learning or in the event learning, what are the opportunities for the students?
Now we focus on student-centric learning opportunities. Long back, that was not a culture. Now, innovation ecosystem is part of the curriculum delivery now. We are able to inculcate the innovation culture among the students, faculty member, join together how the idea with the creativity can be converted into a product with a different technology readiness level. Then you will be given an opportunity to make it as a product. Again, as said by our president, it is a need for the community. Like we have seen a product like ventilator or firefighting robo. These are all the projects we are making as a fine engineering and technology graduate student project. But now the opportunity given by Government of India, Startup India, and various ministries, they offer many opportunities to convert your idea into a product. For example, Smart India Hackathon. And there is a innovation ecosystem by Ministry of Defense called Innovation for Defense Excellence. Under DIO, they provide problem challenges under various defense sectors, Indian Army, Navy, Air Force. I would like to highlight one case study. As a faculty or as a researcher, I have combined the student community and the faculty. We joined together And we are the winner of Defense India Startup Challenge 7. And as said in the morning, we have been felicitated directly by the Honorable Raksha Mantri and Prime Minister. We are working for developing autonomous operation for Indian Navy. Unmanned submarine is coming up by Indian Navy. Like Indian Army, there is tankers, Arjun and Bhishma tankers. Don't think that you are all first year or second year student or engineering final year student. You are all individual innovators. You join hands with engineering and technology professionals in various departments, faculty members, experts from industries join hands with the TEMS India professionals and work for developing a product with various technology readiness level, minimum viable product concepts. So certainly now the innovation ecosystem now is part of academic culture in major higher education institutions in India that drives a student to be converted into a successful entrepreneur with a theme on convert your idea knowledge into business model. That's my experience and I hope all of you can explore. July 31st is an open challenge announced by Ministry of Defense under IDEX and MSME Hackathon announced for 15 lakh seed money. You can submit your idea on emerging technologies of Industry 4.0 and 5.0. This opportunity given to you, not for us in the long back, but utilize this opportunity as a scientific entrepreneur and innovator. Thank you.
Thank you, sir. So we have understood what is the student takeaway from IEEE TEMS. Now I would like to move to young professionals. So we have with us Dr. Arun. And I would like to have a question with Dr. Arun. In this age of AI, how should young engineers adapt themselves and what role IEEE TEMS will play to help them to be ready with the AI models and new AI tools?
Yeah. Thank you very much. Thanks for that question. So recently I was looking at a So I was looking at a recent report. It's called the National Employment Report Survey, and very eye-opening numbers. Right? According to that, only about less than a third of engineers continue to be working in their chosen profession about 10 years later. Right? That means if you are an electrical engineer, electronics, or computer science, or mechanical, whatever, there's a very good chance that 10 years from now, you would not be working in that discipline, you'll be working in some other nearby discipline. And what it means is that you have a choice of either wandering through a career and sort of reaching where you eventually want to be, or taking deliberate steps and then finding the path of your choosing, or your interest, and using your engineering degree as a very good building block to reach that eventual career. Right? So, as you graduate and get to be your initial years of your working as a professional, either in academia or in industry, right, having a good visibility of where you want to be is going to be important. A part of that is to figure out what other disciplines are going to be providing, what they need and what you can do, whether it's product management or marketing or sales or finance or people management. All of those are skills that you need to definitely pick up and do. Now, when it comes to AI, right? So the core area of your discipline, actually finding solutions to problems that are defined, I think that AI does a great job today. Many of you would be using it, right? And like a president mentioned, finding solutions to problems is really not the answer to everything, right? You need to find problems which you want to solve. And that's something which AI can't really do the job. You need to find out where you want to be in your career and find the problems that you want to solve to get there. And if you use a forum like TEMS, right, it provides you very, very wide spectrum of professionals and skills that you can work with and interact with. I think that gives you exposure to a lot more at a much earlier stage than many of us had when we were young. So having that exposure will let you figure out what is the actual career path you want to take, and then figure out the right direction to get there. So an organization like TEMS, by being a part of that, and by seeing where your particular interests lie, you will get an opportunity to interact with the best people in those specific disciplines and accelerate your career much, much faster than it was. And specifically around AI. So eventually, when rubber meets the road, when you want to take a product to market, when you want to take an idea to the actual users, right? So you are having two aspects. One is the technical part of solving the actual problem that you are trying to solve, and then finding the way to make that really solve the end user's problems. And that is something which AI really can't do today, right? It can give you all the technical bits and pieces that you need to figure out how to put together to actually come up with a solution for the end users. So without having those background, you really would have just a nice idea without taking it to the market. Right, so TEMS again provides you the experts, the opportunity, and that will allow you to gain an accelerated career path in your chosen profession. Yeah, thanks.
So here what we understand is like we should know the problem, we should explore the problem, and TEMS will help you to identify the pathway. And as an academician, what I feel is when we have a problem as a student, we should approach our faculty members, collaborate with them, and come up with a solution. That should not be only a publication, but it should come as a product which can be utilized by the society. So let us...
They can do this collaboration. You can do this collaboration globally. I just interrupted Samisha ma'am here. If you're a part of TEMS, you could sit here and work with your problem across continents, basically, because that's the opportunity we provide. We provide an opportunity for networking, which is fabulous.
Thank you. So now I would like to move to Kulandeval sir. We have many faculty members here, and in any engineering education, we heavily depend on an academic leader, and who really understand the problem, try to bring up the solution and guide the students. So how does TEMS involvement empower faculty members to organize milestone events like international conferences, some workshops, or maybe a hackathon? So could you please highlight on that, sir?
Hello. Hello, hello. Hello. Yes, madam. So I'm sure most of the faculty members are already IEEE members. So I hope more members will join IEEE TEMS, because which is going to give you a link between technology, engineering, and management. And as everybody knows, IEEE TEMS supports in networking. So what is happening here? Networking or collaboration or professional development or access to cutting edge technologies. Because just now sir was also telling about Industry 4.0 or 5.0. So what we have to do is we have to empower the faculty members to do lot of programs. They should be able to conduct lot of faculty development programs. They should be given an option to conduct more industry institute related activities. I'm happy that we have Vice President of HCL also with us. So we have to build more industry academic relations, so that which is going to increase the institution's visibility also. Now this IEEE TEMS, whatever we have done, so as a IEEE TEMS member, the faculty can develop the skills. So like a leadership skills they can develop, and they are going to support innovation and entrepreneurship also. So which is really going to help them. As a faculty member, I am telling for them, because we are all talking about National Board of Accreditation, where we are concentrating more on outcome-based education. So whatever is related to that, we have to help them in developing the curriculum or designing or updating the curriculum, or we have to start having more project-based work so that the faculty can be empowered with this IEEE TEMS. So try to involve with more organizations, try to collaborate, try to visit national level or international level programs. So which is really going to give you with more research areas also, because people are talking about like Web of Science, or we talk about Scopus papers. So IEEE Explorer is giving everything to you once you become member. So TEMS is going to support you a lot. I'm sure we'll be able to develop our skills. As Susindra sir was telling, as a student, you start telling hello. So like this, once you start interacting with all the faculty members, all the industry people, all the guests, you get a confidence. So which is really going to help all of us. Thank you.
Thank you. Thank you, sir. Madam, you would like to...
Yeah, just adding on to what Sir said, that if faculty members want to organize programs to introduce concepts to students on an international level, there's something in TEMS called distinguished lectures, right? So we'll be funding overseas travel as well for such lecturers that we have impaneled. So you can visit our websites, dear faculty members, to find out who they are. We have exceptional speakers. Please invite them over. We'll be happy to provide the contacts.
Thank you so much, ma'am. I think faculty members should definitely visit right away after this program and see what are the opportunities available for you. So please visit the website and find out like where you can collaborate, where you can travel, and TEMS is there to support you. So let's take a pause here. I am seeing a lot of students nodding here. So I would like to come to audience to take a few questions. Could you please raise your hand so that we can send mic there? Anyone has any question? At least one or two?
See, women are leading the way, so happy to see that.
Exactly.
Mike,
Good afternoon. I am Sri Ashni from Department of ECE, and my question is that what common mistakes do young graduates make after entering into the industry, and how can they avoid that?
Arun sir?
I think that's a great question. Right. So what year are you in?
I am from ECE department.
And which year are you studying?
I am from third year.
Okay, so you're almost on the verge of joining the workforce. Okay, so first, I don't think there is a single set of mistakes that young people do on joining the workforce. I think probably the single most important thing they should do to sort of avoid any potential mistake is set their expectations right. I think the actual mistakes that people do are not really that important as what you expect the work to be once you join the workforce. Right? Many people assume that what you have learned is really what you would need to do in work, and that's rarely the case. Right? Almost, I mean, we have many people from the industry here, and I'm sure they'll all tell you the same thing, that what you learned is something which is probably only going to be useful maybe 20%, 30% in your actual work that you do there, and there's a lot of learning to be done. So essentially, unless you gear yourself up to know that what you have studied is only setting up the foundation, and you have to do a lot more learning in order to be actually effective at the work that you do, right, you would actually find yourself at a loose end. So if you set your expectations right and make sure that you go with the right mindset, that there is only a quarter of the learning that you have done and there is still 3/4 of learning that you need to do once you start working, then I think you will do a great job. I think everybody, if they start with that expectation, I think it will be fantastic. That's all you need to do. That's my view.
Thank you. Any other question? So I think with this we would like to conclude. So thank you all the panelists for mapping a blueprint for the student to understand how they can collaborate and how they can work with the TEMS leadership and TEMS chapter at their institution. So as we conclude our discussion, it is very evident that next chapter of technology evolution requires leader who don't just understand data, but they understand people, strategy, and societal purpose. That is where we at TEMS support the entire community. The future cannot just be predicted. It must be managed and led. IEEE TEMS give you the global platform to do both. Do not just join the society, actively drive it, and let it drive your career. Thank you. Thank you to the management of the Sri Manakula Vinayagar Engineering College.
Can I just take one moment?
Yes, sir.
Yeah. So, there are many things many of us have said, but if there's one last thing I do hope you take away from all of this is, I want to refer back to what Mr. Rajarajan said, right? You need to be a T-shaped professional. And if you don't take away anything else, but remember that T stands for TEMS. And if you want to be a T-shaped professional, TEMS is the place to be in. That's all you need to remember and go and look at TEMS. Yeah.
Thank you, sir. Yeah.
Thank you. On behalf of TEMS India, TEMS Global, we thank Dr. Samiksha for your panel moderator and bringing all the panelists here and connecting the dots between young professional, women in engineering affinity group, students, faculty team. So thank you all on behalf of our TEMS Global team. We thank all the panelists here. Thank you so much.
Thank you.
We'll take one.
Thank you all for the engaging and insightful discussion. Thank you all. I invite IEEE teams members to honor IEEE Madras section members. I request Dr. Arun, Dr. Nagarajan sir, Dr. Kurandeval sir, and other members of IEEE Madras section, please join us. Now we move on to the industry talk. It's my pleasure to introduce our distinguished industry speaker, Dr. G. Sai Narayanan, Global Technology Director, Engineering and Research Services, HCL Tech. He holds a PhD in image processing, a master's in control systems, and master in law specializing in intellectual property rights, and has completed an executive program in advanced strategy management from IIM. With 25 years of experience across academia, research, and industry, he is a renowned expert in computer vision, machine learning, and engineering innovation. He has an impressive portfolio of 20 granted patents and over 125 technical publications, including books, book chapters, and research papers. A senior member of IEEE, he also serves as Vice Chairman of IEEE Computational Intelligence Society and Executive Committee member of the IEEE Signal Processing Society, Madras chapter, contributing significantly to the advancement of technology and professional excellence. Ladies and gentlemen, please join me in extending a warm welcome to Dr. G. Sai Narayanan sir, Associate Vice President, HCL Tech, to deliver the industry talk.
Thank you, madam. Very good afternoon, all. I won't take much time before your lunch, but this is a very proud moment now, exactly 5 minutes back. Can you tell what is that? India has launched its first private spacecraft, Skyroot, and it has been launched very successfully, right? And I was watching the news now, and it crossed all the stages and it reached the space. And it's the first private space program from India, right? And that too with a lot of technology management things are happening, like our celebration. This is a very proud moment. You can remember this day forever, right? This program, and like many speakers are also making it very memorable, that you will be like, always when you hear about any space programs, you can always remember, right? And you read through the story of Skyroot space. It is almost like 8-9 years back, they started this building a spacecraft. Only the government were in the launch vehicles, like building rockets to send satellites. And they started where there is no funding ecosystem, where there was no proper governing laws, who can and what is the safety conditions they should launch. And they started, they got funding. Now they are 1 billion organization, and they have launched the first private satellite. And this has opened a lot of space for carriers in space as well, right? Yeah, it's a very proud moment. Like I'll join you also to send my wishes and congratulations to the team which have worked begin that. Okay. So I wanted Dr. Purkumaran also to join this when I tell this, that's why I holded him. Okay, today's my, like you can get this. So here, like today's my talk is on AI innovation, right? AI driven innovation for engineering management. Say you will be hearing a lot of AI, how it is going to disturb your future career, whether like it is a lot of saying like AI, people are losing jobs, people are like replaced, right? And many of you have very ambitious, you might have taken courses in AI, you might be doing a lot of hackathons in AI, right? I just want to touch upon this area and what is the opportunity there, what is the challenges now, and that opens doors for your opportunity, okay? So here in the, like what I will be covering is on like what is the canvas of AI progression, how AI has developed over years, a slide on that. Then how it's in different field, how it is doing in semiconductor, like silicon development, right, software, mechanical engineering, aerospace, right, how it is touching every of it, every engineering specialization, and what are the open technical challenges, and 3 to 5 years from now, right, what is going to happen predictably, right, what is going to happen and how you should be ready with that. Then what type of governance and management is coming to that? As I was saying about aerospace, there was no governance was there earlier. Now there is a lot of governance, lot of guidelines have come to place. Similarly for AI also, it start picking up. What type of governance management, which you should be knowing it. Say if you are having an automobile, you are building an automobile, there is a standard guidelines how the automobile has to be built, right? There is a type of certification. If you build a consumer electronics, right, then there is a certification for it. You will see CE type of thing or ISO, right, ISI type of thing. There is a standard like how you should be built, what is the safety standards, everything. Similarly for AI, the standards are evolving. You should be aware of that. And we will see what are the takeaways. So when you talk about the AI, right, it came in 4 different waves. In 2000, we call it as a classical machine learning, right, where it may be started 1960, but where you start more application coming into the pitch, when there is a lot of e-commerce coming into the place, right, lot of online platforms coming into the place, this classical machine learning algorithms were also being placed. Like when you buy something in Amazon, a system shows that this may be a relevant product for you to buy, right, or based on your usage pattern, some advertisement coming into your email, right, or you based on your email transactions, some mails come. All these things are like from the classical machine learning were there. But the challenge was, right, everything has to be, we call as a handcrafted. You need to tell AI, right, you need to give the data, like if you see this pattern, you should do this. You should see this pattern, you should do this. So that was a lot of a handcrafted, we call it a handcrafted. You need to tell, right, if you say if you are a banking application, you are building a banking application, you want to give a loan, you have to tell this is the age of the person, this is the job, salary, this is credit score, right? All that you need to tell that which will be relevant for the machine learning to take the right decision. That is called features, right? You need to tell explicitly these are the key component you should understand to make a decision. That was the classical machine learning. Then we had a deep learning where you give the data, the machine learning will try to learn by itself what feature you should consider for taking decision, right? What feature you need to, if you are identifying a face, what type of feature? If you are identifying a fingerprint or you are identifying a video security, it identifies by itself. That is called feature learning, right? Feature learning happened in the deep learning. That was one thing happened from 2016, where you see a lot of computer vision based applications came in, or a speech based application came in, or speech translations, language translations all came in. Then we got into a next stage called as transformer stage, right, where the generative AI, your ChatGPT or Gemini, right, all that started coming in when there is something called transformer was being introduced, right, in 2017-18. This got a lot of attention. People started doing a lot of research. Now from the generative AI, we are moving something called as a agentic AI. So till generative AI, it was like a suggestion what to be done. The suggestion was given. The agentic AI phase, right, it gives agents try to plan by itself, try to execute things. It is trying to do things on its as per it is been programmed or as per it is has learned, right. So as such movement has come from a type of a generation or a suggestion to a execution, right. That is a agentic AI, but all has its challenges. The generative AI transformer has a challenge, right. We call it as an hallucination. That means it can generate, it can be more creative, it can give some inputs which may not be true also, right, which may not be true. That it has to be true means we call it as a grounding. Grounding means it has to be placed on a particular facts, right. Your facts were sometimes without facts things were able to give. So people are building like how to be more grounded. Grounded means how to make decision based on the facts, right. That was, then we have an agentic. Again the agentic, like when you are allowing this machine to take decision on its own, right, and you will be using lot of frameworks today, which is an autonomous decision, which is a guided decision, right. You may put some rules to take a decision, but whether the AI is following the rules, right, then that becomes a challenge, right. So these are the different phases of AI. When it comes to the growth, right, in this AI space or generative AI space, right, it is growing very fast. It is expected to be growing at a phase of 37%. It is growing. I mean, CAGR is a common name. When you get into a market understanding of any field, you will understand. I mean, what rate is a cumulative average growth rate? At what rate a particular field is growing? You need to know when you are looking at some field, you want to choose some field, you should know how it is growing, right? And it's growing at 37%. And the total market value, right, what they are getting is about 214 billion. Why I'm giving these figures, right? That is the type of opportunity you will have it here for either to build new organization or to work for an organization. There is a huge opportunity in this area, right? So it is growing fast. But what is actually like, why it is growing, right? Why it is going? Why AI is growing? Because like if you see in a software development, right, in a software development, pure coding, there is already 90% penetration to use AI, right? And everyone, like 90% of the organization, like it says that Fortune 100 companies, right? 90% of the Fortune 100 companies are using Copilot. We call it Copilot means something parallelly sitting with you to help you, right? So they started using a coding Copilot. Coding Copilot means it will try to give codes for you. You want to do a function, you need not write everything, it will take, but you have to verify it. That is a 90%. And there is always a talent gap happens in industry, right? When people retire, all these talent senior gaps or the domain specific gaps, AI start filling it. AI is able to guide it, able to learn that type of things, and it started guiding. And many of the products, right, the time to market, we call it, when you design some product, you think with the companies, right, if Apple wants to launch its Apple 18, right, they will see how fast they can go to market, right? There is a time to market. That time to market also, the market is demanding faster, compressed year, instead of like compressed number of days. Earlier, if they are trying to launch it at 24 months, they may be looking for it to launch in 12 months, right? That means the faster new features will come to the market. That is a demand of the market, right? AI is helping them to go to market very fast, right? How it's going, we will see. And also the model maturities, AI model maturities, like we might be hearing about Claude, you may be hearing about Gemini. All these model maturities are been like have gone like a very, very high maturity level, right? It is like working excellently. It has a model wise, we are getting into a type of a stable state. Model is good. We are getting, and the tools, right? We call it, and if you are a EC engineer, you want to design a VLSI, right? For a VLSI, one ASIC to come out from the design to tape out or manufacturing, it will easily take 3 years, because there is a lot of designing process are there. All these are getting automated. We call it a EDA process, right? Engineering design adoption. All this one are getting a type of like how to say, like very fast. Now all these tools, like you might have heard of tools like Synapsys or Cadence, all are getting integrated with the AI, right? So people are doing it very fast, right? The expectations of the companies or organizations, like they want to shrink that whole development cycle or it by 30-40%, they are reducing it, right? And AI is no more an experiment now in industry, right? It has become a CEO mandate. CEO mandate at CEO level at every organization. What is the adoption of AI? What is the revenue they are making from AI is being tracked, right? So if you see in our organization also, like from last 3-4 quarters, they started reporting how much is their AI revenue, right? Every organization start reporting. That shows the importance of it, right? There was a myth like AI will not do things, AI will not. That stage we have crossed. Real adoption have come into place, right? Real adoption have come into, people started using it for things. But, right, 93% of people, right, are willing to use AI to make it faster, but only 3% have succeeded. Okay, there is a gap here, right? 93% have tried and they feel like it is working, the proof of concept or pilot, all are doing good. But when they want to put it into the real world working, right, only 3% of them are able to succeed. Succeed in sense, able to see the benefit out of it, right? That is a contradictory statement. Earlier I was saying it is working, adapted, all that are things. But that means 93% is adapting. But only 3% of them, they are able to gain, do a high gain. Like I would say it's not a gaining, able to gain a high gain. That is again the challenge is there. Like the challenge, where the challenge comes in, right? In real world, these are the skills problem statement you should understand when you are choosing a project, when you are trying to do some AI projects or you want to see how AI thinks. The main challenge comes in any industry, the data are in silos, means the data are distributed, right? Even when you are doing a project, you should see how if every data is available ready for you, you can easily solve. But if the data are complex, it's distributed, then it becomes up. So the main challenge is the data are distributed. And many of the tools are legacy tools. Legacy tools means if you are working in doing a CAD design or a circuit design, some of the tools are legacy, they are not able to bring automation in that. So that is again a type of a challenge. So there is a real practical challenge we are seeing because of the data, because of the infrastructure, that means the thing. And there is a type of a weak, we call it a weak data strategy, right? How the data has to be maintained is very, very important. That is again, it's an industrial problem. I don't want to go into that. But when you come to where all it is been observed, right, or where all it has been success, in a product development life cycle, say for example, take a product, a car, right? You want to develop a car, a manufacturer, maybe a Toyota is making a car, right? In the product life cycle, where all it is getting adapted, right? That is very, very high. Say it is making like if something is a type of boilerplate, we call boilerplate means it's a repeatable things, which are not, there is nothing, it's already been manufactured, you are only repeating the same thing, right? Already there is a design that has been repeated. Those type of repeatable tasks are getting automated. It is getting a faster observing, and wherever there is a testing need to be done of a product, the testing with AI has also increased, a test coverage of thing. The why I am telling this, when many of your, I have been interacting with colleges, many of them when they want to do an AI project, we take an ambitious a problem statement and we will try to use an AI and to solve. That will only give a type of a value to it, right, or a type of a good feel to it. But you select a problem which are real challenges in the field, right? A testing is a real challenge. How to use AI to test a software code? How to use a AI to test a semiconductor design, right? You are having, right? How to use AI to test your mechanical design, right? You want to do a finite element analysis of a mechanical or a test or something. How to use AI to do it? Those type of things are very, very important. So in a product life cycle also, there is lot of adoption. Even a software development, nowadays we call it as an AI pair programming, right? AI pair programming, we call it as a type of a communication is very important, right? Now communication between a person to person is very important. At the same time, person to AI is also getting more important. It all depends how you tell an AI to tell it. Are you giving the right information? Are you conveying it clearly? Are you giving a correct context to an AI? That is very important. So that we call it as a prompt engineering. You might have heard these names. Prompt engineering is nothing but how you are able to communicate with your AI system. That is also getting important. So in software there is a lot of adoption. Then the EDA process, right? The EDA is mainly your VLSI designs, VLSI generating a VHDL, RTL code, right? One of the early adopter and highly observed productivity gain is from the semiconductor design, right? We may think semiconductor design is very complex, how AI can do all these things. No, it has been adopted. The tools like in terms of the Cadence, right, MediaTek, they already have integrated AI into the product development cycle, right? They have so whenever you are like doing, say you may be a mechanical engineer or you may be electrical engineer or you want to get into communication, so try to understand what is the AI adoption in your field, right? And choose something like understand what is the challenge in the AI adoption, right? Don't try to solve a big objective or a product level, a high problem. Take a simpler problem where there is a challenge in AI adoption. If you are interested to go take your career along with AI, which is inevitable. Everyone, like even if it's a project management, even it's a finance, even it's a lawyer or a media, everywhere is getting penetrated. So, but we need to understand how to work with that, right? It's only making people's life easier, but there is a lot of risk involved in that. Right? So similarly, like in a CAD, making a mechanical designs, right? Mechanical designs, there are many tools like you might have heard of CAD, you might have heard of, there is something called Creo, there is a type of Revit, there is a different mechanical software. Even that creating a turbine engine, right? Turbine engine, the design, right? There's a lot of AI assistants have come. What type of thing? People are designing a high volume coolers, right? High volume coolers, which part to be placed to where, so that like the center of gravity stays in the center, right? Those type of design aspects also is getting automated. So I'm not getting into the next main thing you need to, if you are from mechanical side of mechanical engineering or a civil engineering or in terms of electrical, there is something called physics informed AI. which is getting very, very important, because the challenge is always with the generative AI, it can generate things. I cannot design an aircraft listening to an AI, right? Because some basic physics might be violated, right? I cannot design a biomedical device just by saying that this is a design parameter. I have to be exactly, so you are doing something, a type of a heart blood flow monitoring device, right? You want to control a blood flow during an operation you are doing, right? We cannot design something. So there is something called physics informed, where the constraints are all your physics equations are getting into AI, and the main safety critical equipments, they are moving to this something called physics informed AI, which I would suggest you to explore this area, right? When you are using AI, think of like what is a physics based, physics inspired model, physics inspired neural networks, right? Those are the area is another, if you are thinking. And oil and gas, that is a very big field, because oil and gas has lots of data. If they are drilling, there is a lot of seismographic graphs, there is a lot of records coming in, safety records, all this comes in, and whenever something has to be, say maybe take an example, it's an oil refinery plant. It may have thousands of control valves, thousands of actuators, right? You boilers, you have turbines, all that thing. If you want to, some problem happens in a particular control valve, they need earlier they used to go and look for files, what is a control valve number, product number, they have, now it is very simple. People go with a handheld device, they take the picture of it, right? From the surrounding, which line number, it auto identifies, get the service records automatically, and also when it service, are there spares available in the factory to replace it. So those type of the data, the servicing itself is getting highly automated, or highly automated assisters in things. That is another area. Even in energy, something you might have heard of, something called digital twin, right? Digital twin is nothing but you create a digital model of any device, right? It may be your car, you want to create a digital model of the car and you want to run experiment on it, so that you can test your extreme conditions of it, right? Those type of digital model. Even the like type of a, it may be a windmill, right? Windmill, there are digital twins are available. Every mechanical or electrical or mechatronic devices, people are building digital twins. That is another area, how to use AI to create a digital twin. That is another area I want you to understand as well. Okay. So basically, like you have software, there is an adoption, but there's challenge there. Like look at the last column, innovation required, where there is a problems for you to pick up. In a software, how to verify a AI written code, how to verify a AI written code so that there is no security violations are there. For example, you are using an AI to write a code, and the code has given some malware into it, some a problematic code into it, right? If you doesn't know that, if you deploy it in your machine or deploy it in your application, it can start sending the data outside, or it can be hacked easily, right? So even it is being generated, how to verify the AI written code, that is a big area. And if a human writes in, an expert writes in, he may write in 100 lines, AI may write in 200 lines. Again, it becomes a large code to manage, or to the size of the code will get increased. All those problems are there. Still there is a gap there for you to pick up problem. And the silicon mainly, like if you are designing a chip, right, how you can trust that design, the trustability. Now it is more of a human in the loop process. It is doing the repeatable task easily, but someone has to validate it. So how to bring the trust into the AI is very, very, very critical in the silicon. A mechanical, right? Yeah, mechanical, like lot of certifications are required when you are creating. So how a compliance is being adapted when you are using AI. Similarly, every field has its challenges. You can go to think every field there is an AI challenges which you can adapt, right? So to say that, like what is slowing down, or like what has been a type of a speed breaker for a quick adoption, that means the 3% people started saying how you can, your role in next 5 years, your role will be how to make the 3% to 30%, or how to make the 3% to 60%. That means all the models, AI models are available, it is matured. all the like infrastructure, the computing facilities are available, but the reliability is what? Still lacking, right? When you are adapting in your field, how you can bring the reliability, how you can bring that trust into it, right? So the security into it, that is the very, very, very important, which I want you to take this as a thought process when you are doing some projects in the AI. So if you say that you have used agentic AI, I used AI like a ChatGPT or cloud to solve this problem, and you add a part to it, how you have made it more reliable, how you have used a trustability in that, right? Because there's a lot of standards are coming in. Like I'll get into that. Lots of standards are coming in. Like in terms of like there are ISO standards are coming in. Look at that ISO standards, right? And when you're doing the project, you say the 5 points of this ISO standard I have adapted into my project. This 5 like points I have taken it for the security purpose I have adapted. This is for auditing purpose I have adapted this, so that like my project is well organized. This is my GitHub code where you can go and see this code is been developed as per this ISO standard of AI adoption, right? Or safety standard of ISO adoption. If you make the statement in your resumes, right? If you make the statement in your resumes, that makes a lot of differences, right? Because still there's many new companies who are adapting AI are struggling in the area, right? And this is where you can make a differentiator. So there are some, even you can look at it, it's not only the few papers, there are a lot of papers we have like where the problems which are being addressed by different researchers for the real adoption, right? Handling the hallucinations or handling the digital twin or the physics informed neural networks, right? These are the different problems you see in the recent IEEE forums it be discussed or presented, right, or published, right? So look at these problems. Don't go with the type of you may think of some fancy problems maybe look attractive, but the real differentiation comes how trustably you have done this, right? How efficiently you have done it. That is a main differentiation you can bring it to your profile. So next 5 years, right? 3 to 5 years. One major things in engineering which is going to drive the lot of things is called as physics constrained AI or physics inspired neural network, right? This is one area where not much expertise is available. Not much expertise available in the whole AI ecosystem. This is one area because you are new, you have learned maths recently. You know how to solve the differential equation. If you ask someone graduated 10, 15 years back, he might have forgotten, right? So all these are like you know how your Newton laws work, how your like fluid dynamics works, right? So all these are like things which need to go into the AI here, right? So this is where like you have an advantage. You will understand the maths better than someone graduated 10, 15 years back, right? So this is a value you can bring in. Say that I have designed a digital twin of a small electrical motor, right? Where I have put physics constraint into that so that it works as per the real time how a motor works. I'm able to drive an AI model into that, right? If we can make the statement, right, that is going to be a simple braking system in your car, right? And you have these physical constraints to it, into that and design that model. That is again another differentiator. Then things are like from assistant, right? Now we call this a co-pilot, right? That is a co-pilot means which is going to help you. From there it is going to be autonomous. Things are going to do on its own, right? So you don't need a human monitoring. That is where it is trending, and the transition or the growth is happening in a very fast pace, and whatever we are seeing in like a problem which you are not solving today, right? We are seeing in a 2-3 weeks of time, there are new model coming or new approaches, frameworks coming in, they are solving it. So it's very fast, things are changing. So again, like these are the areas are highly like silicon or software, aerospace, right? Or sustainability, governance. So you can pick up some of the problems here and you can work on that, right? And I was telling about your frameworks for AI, right? How to govern it, how to like, this is where when you do a project, if you say that I have adapted ISO 42001, this is one ISO standard. Currently, it is been very active, right? So you can look at what are the, you say now it's very simple. You use a Claude or use an thing, you describe your project, this is my project, I'm doing this project, and I want to make this as a compliant with this ISO standard, what I should do, right? If you ask it rightly, you will give 10 points what should do for the project. Try to implement in your project. Okay? Or if you have patience, read through the SO and pick up the problem. So these are very, and there is something called NIST-AF or thing, like this is another standard coming in, or European AA Act, right? So there are standards being evolved. There are many fields where the standards are, application of AA is not been standardized also. This is a one area where if you can build that AA regulatory specialist role type of thing, right, which is a key demand in every industries, right? If you say that I'm interested here, I've done my project in this area and I'm able to demonstrate, right? So I would say 5 things I want you to think, right? How AA converged, right? Different stages. Then what is the bottleneck now, right? It's mainly is a model we have matured. Only the data and the trust is what we are lacking, because data are distributed, the trust is not able to be demonstrated, right? And agentic engineering is the next 5 years. I want to agentic engineering and physics informed models are very, very key in next thing. And governance, right? The governance can give a competitive advantage for you when you are getting into the governance of AA. And if you are making your code to be a properly governed, AA governed standard codes, again there is a differentiator, right? So I would say that for students, the field is very open. You have so much opportunity in AA. And even if you are in any discipline, right, see that how it is been. I'm not saying that the traditional engineering will go off, nothing. If there are 5 positions, how to get the 5 position is what I'm looking at. Okay, so to be a competitive, try to get some adoption of AA into your. If you are purely a physics person and I don't want like an AA, I want everything thing, I'll tell you, it is getting penetrated into every field. You can use it as a type of an assistance or a type of inspiration or a type of a thing to get it. So there is a lot of scopes to that. So the best time to start this journey is yesterday, right? We already across. So if not, the next best time is now. Okay, so you try to get into this area. Don't think of like a model building. Don't think of like a type of solving a problem. Focus little, shift your thoughts along with the problems I told you, where there is a real problems, where the innovations are required, right? See, if you are able to build some AI solution, credible, the startup or the funding opportunities in this area are huge, because many companies are shifting their funding. Many equity firms are shifting the fundings to an AA. You might have heard of something called Swarnam AI or something. It's an Indian-based AI models. People are building it, right? And in a very short time, it has reached 1 billion valuation. And these are not something like unreachable or like thing. It's only the right problem you select, right? The right problem in the field you select, and you should be ready to be adaptive in changing the problem as well, because things are changing very fast, right? If you can bring up some innovative solutions where the current AI is being like challenged, right? Adoption AI is challenged. That will be a feature which you can grow on, right? With this, I'll conclude my talk. I think I didn't take time. If any questions, I'll be happy to answer.
Sir, good afternoon, sir. I'm Maulishwar from Department of ECE. And my question is, even though some industry invests in AI, why they face some losses, sir?
A very good point. See, it doesn't mean AI will give a profit, right? The profit depends on many things. Profit depends on many things, whether they are selling the product rightly, right? They are like, there is a marketing is done rightly, the sales is being done rightly, the delivery is being done rightly, right? So the AI, what AI can bring in this whole life cycle, it can reduce your time to develop. It can reduce your cost, right? But if you don't use AI properly, the cost can go high also, right? Cost. So it's not that if you adapt AI, they will be profitable. Okay, that is one point. But if you want to, there is a good levers in AI which can make it as a type of the reduction in the cost. If you see like recently some statement with one of the leading IT service provider, their ambition is to have as many agents as the employees, right? The company is having about 4 lakh, 5 lakh employees. They said they will build about 4 lakh, 5 lakh agents in the system, right? That means like they are going to double their power, right? The cost for the human proper engineer will be higher than the agent, right? So the cost will, average cost will come down. They can become profitable. Thank you.
Thank you, sir.
Okay, thank you friends. Like I'll be around if you want to discuss or chat on anything, like we can do. Thank you very much.
Thank you, sir, for the insightful address. I take the privilege of proposing vote of thanks for this celebration. First and foremost, I would like to thank our management members, Sri M. Dhanasekaran sir, Chairman and Managing Director, Sri Rajarajan sir, our Treasurer, and our Joint Secretary, for granting us permission to host this institution in our campus. And I would like to thank our Director cum Principal, Dr. V.S.K. Venkatachalapathy sir. He is the guiding force behind the successful organization of this program. I thank him. And I also thank Dr. Porkumaran Karantaraj, Chair, TEMS India. From the day one, he is in contact with the organizing team in the successful implementation of this program. And I thank Dr. Sudhindra Kaushik, President IEEE TEMS, and all the panelist members, Dr. Maushikakar, and Dr. Arun Tangshali, and Dr. Kulandevel, and Dr. Samiksha, for giving us the engaging and insightful panel discussion. And I thank the industry expert member, Dr. Sai Narayanan, Associate Vice President, HCL Tech, for giving us an input on AI. And I thank the Controller of Examination, Dean Academics, Dean Placement, and Dean Research for guiding us in organizing this event. I thank all the faculty members for being with us till the entire session of the day. And I thank the student members. So you are the most valuable resource for this day. I hope you people might have taken some inputs from this session. I thank everyone. Let us all stand and be proud to sing our national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे